Now what is geometric series? Series, okay, before that, what you should know, what is geometric progression. See, this is geometric progression: ar, ar square, ar cube, okay, ar square, ar cube, and so on. This is called a what geometric progression. Okay, why it is called geometric progression? You will find that what if you divide ar by a, that is second term by first term, what we get, ar divided by a is equal to r. If you divide ar square by ar, what we get r again. If we divide ar cube by ar square, again we get r. So what is meaning of that? We have common ratio equal to r. Okay, and that is why it is called what, a geometric progression. So it has common ratio equal to r. Okay, so first term of this geometric progression is a, and common ratio is r. So this is what common, this is called common ratio, cr, common ratio. And what is first term? So first term, ft, first term is equal to a. Okay, now if you remove this comma and if you add, see, if you remove this comma and if you remove that by plus, so a plus ar square plus ar cube and so on, plus and so on, this becomes a what, geometric series. Okay, geometric progression becomes geometric series. So this is a geometric series. Why it is geometric series? Because it is addition of what terms of geometric progression: a plus ar square plus ar cube plus and so on, ar raised to n minus 1. Note that this is the nth term of that gp. This is your un, nth term of gp. And then what you have, un plus 1, un plus 2 up to u infinity. Now what if you want to find its summation? Summation will be given by ready-made formula. So this is what n, first n terms of gp, it is given by a times 1 minus r raised to n divided by 1 minus r, provided what, common ratio is less than 1. If common ratio value is less than 1, okay, if it is 1 half, if it is 1 by 3, if it is 1 by 9, if it is 1 by 2, okay, if it is 1 by what something, okay, that number between 2 to 9, then what it will be, what, having this formula Sn equal to a inside bracket 1 minus r is divided by 1 minus r, provided r is less than 1. And for r greater than 1, we have what, just change in the formula, r is to n minus 1 divided by r minus 1. Okay, also limit n tends to infinity Sn. Now this is very important. Limit n tends to infinity Sn, yes, that is limit n tends to infinity what of this. Okay, so limit n tends to infinity of this will become what, a divided by 1 minus r. How? Because if you take what, n tends to infinity, yes, we get r raised to infinity. And note that if r is less than 1, okay, so if it is greater than 0 and less than 1, means it will be like a value between 0.1, 0.2, 0.3 and so on up to 0.9. And we see that 0.1 square is 0.01, 0.1 cube is 0.001, 0.1 raised to 4 is 0.001, and so on. So we observe that this factor r raised to infinity is what, very very small if we increase the value of n, and if it is infinity, it what definitely is going to become 0. So this becomes 0, and due to that this term vanishes. And if this term vanishes or this term vanishes, what we get, a into 1. So this is a into 1, a into 1 and divided by 1 minus r. Okay, this will happen. So what is the sum of infinite terms of geometric progression? It is simply given by first term divided by 1 minus common ratio. Okay, so first term divided by 1 minus common ratio. This is very simple formula. So a plus ar and so on up to ar raised to n minus 1 plus and so on. After that, even that will become what, a divided by 1 minus r. Okay, and it is happening only if r is less than 1. R is less than 1 means it should be greater than 0. That's why we have written what, mod r less than 1. What is meaning of mod r less than 1? R value is in between minus 1 to plus 1. Okay, so if r value is in between minus 1 to plus 1, what we have this. Okay, if r value is greater than 1, what, the series diverges. Okay, if r value is less than 1, the series converges. If r value is greater than 1, series diverges. Okay, so as r value greater than 1, see, we have category like this. Okay, so first of all, what we have, suppose that this is r axis, so we have here r equal to 0. Okay, so r equal to 0, r is equal to 1 and r is equal to minus 1. Okay, This is r is equal to minus 1. So this is what mod r less than 1. Okay, and this part, which part? This part, okay, in union with this part, that is the value of r is greater than 1, okay, and the value of r is less than minus 1. Okay, the value of r is less than minus 1. So these two, this one and this one, that pink regions or pink straight lines will form your mod r greater than 1. So see, you will get convergence if mod r less than 1, and you get divergence if mod r greater than 1. So that is happening for your which series? Geometric series. Okay, so what is the conclusion from this? So geometric series a plus ar square and plus so on, ar raised to n minus 1 plus and so on, it converges, okay, if mod r is less than 1 and its convergent value is a divided by 1 minus r, and if what mod r is greater than 1, it diverges. Okay, it diverges means it is not having value of summation, that's all. Okay, so we can see one example. So suppose that you have infinite series like 1, 2, 4, 8 and so on. Okay, just now we have seen that this is what divergence series. Okay, I have shown you that as limit n tends to infinity. Okay, so here this series will be nothing but what 2 raised to n minus 1. Okay, with un 2 raised to n minus 1. This is your un, and you will find that limit n tends to infinity, limit n tends to infinity of un will become what it will become? It will become limit n tends to infinity 2 raised to n minus 1. Note that if you put n equal to infinity, infinity minus anything is infinity, 2 raised to infinity will become what? Infinity. Okay, and it is not equal to 0. So I have shown you that this series 1 plus 2 plus 4 plus 8 diverges. Okay, because what the nth term limit as n tends to infinity is not equal to 0, it is infinity, it is not equal to 0, it is other than 0, that's why it is what? Divergent. Okay, now let us have a second series 1, 1 by 2, 1 by 4, 1 by 8 and so on. Okay, you will find that what its nth term, what is its nth term? So its nth term is, so for this series the nth term is limit, okay, n tends to infinity, what? 1 upon 2 raised to n minus 1. And if I put n equal to infinity, infinity minus 1 is infinity, 2 raised to infinity is infinity, and 1 upon infinity, so this become 1 upon infinity, 1 upon infinity is equal to 0. Okay, it doesn't mean that it is convergent. So but with the help of the geometric series I am going to show that it is convergent. Okay, and it will be a confirmation of your necessary condition. The infinite series 1, 1 by 2 plus 1 by 4 plus 1 by 8 and so on, 1 by 2 raised to n minus 1. So see, if you put n equal to 1, we get 1. If you put n equal to 2, we get 1 upon 2. If you put n equal to 3, we get 1 upon 4. If you put n equal to 4, 4 minus 1 is 3, 2 raised to 3 is 8, 1 upon 8 and so on. So this is a geometric series. What is geometric series? Because if you divide what 1 by 2 by 1, we get 1 by 2. 1 by 4 by 1 by 2, we get 1 by 2. 1 by 8 by 1 by 4, we get 1 by 2 and so on. So your common ratio is here 1 by 2, which is less than 1. Okay, and a is what? Equal to 1. A means first term. First term is 1. Okay, first term is 1 and common ratio is 1/2, which is less than 1. So r is less than 1. Okay, condition is satisfied, therefore this series converges, and this series converges to, so what is value of this series? This series converges to first term. What is first term? 1, that is a. This is nothing but a divided by 1 minus r. R is what? 1 by 2. Okay, so this is nothing but a, this is nothing but r. So the formula is a divided by 1 minus r. So we get a divided by 1 minus r. A is 1, 1 minus r is 1 by 2. 1 by 2, if you take it to a numerator, it becomes 2. So this converges to 3. Okay, so summation of this is equal to 2. Okay, if you add on infinite terms, we get 2. Okay, now after this we are going to discuss a very important thing, and that we are going to use for even our comparison test, and that is called P series. Okay, so see what is a P series. Okay, now we have started with your test. So let us discuss regarding your P series. What is P series? It is called power series. What is power series? The series of the form. Okay, if you have series of the form, which form? Summation n from 1 to infinity. Okay, 1 upon n raised to p, 1 upon number. If number is 1, 1 raised to p. Okay, number is 2, what? 2 raised to p and 3 raised to p. So if you have series like this, okay, so summation n from 1 to infinity, what? 1 upon n raised to p is equal to, so this is nothing but this. Okay, so if you put n equal to 1, we get 1 upon 1 raised to p. If you put n equal to 2, we get this. If you put n equal to 3, we get this. N equal to 4, we get this, and so on. Okay, so it is what called a power series, because it has power of numbers. So 1 raised to p, 2 raised to p, 3 raised to p, 4 raised to p, plus and so on. So 1 raised to p plus 1 upon 2 raised to p plus 1 upon 3 raised to p plus 1 upon 4 raised to p plus and so on. Note that its nth term will be 1 upon n raised to p. Okay, and plus and so on. So this series has un is equal to 1 upon n raised to p. So this series is convergent. This series will be convergent if value of p is greater than 1, strictly greater than, it should not be 1, it should be strictly greater than 1. And if this value of p is less than what, 1, then that series is divergent. Okay, suppose that you have this series. Suppose you have 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5, okay, and so on. So this series, is it a power series? Yes, it is power series. Why it is power series? Because it is 1 upon 1, so it should be having the form of 1 upon. So 1 upon 1 raised to what, 1, 1 upon 1 raised to 2 raised to 1, 1 upon 3 raised to 1, 1 upon 4 raised to 1, 1 upon 5 raised to 1. So what is value of p here? Value of p is equal to 1. So this series, okay, is a power series with p value equal to 1, and p value equal to 1 will give you a divergent series. On the other hand, if this what series is 1 upon 2 square, 1 upon 2 square, 1 upon 3 square, okay, 1 upon 3 square, 1 upon 4 square, 1 upon 5 square, okay, if you have series like this, then here the value of p will become what, 2, and this series will be convergent. Are you getting my point? So if p value is, okay, suppose that you have been given a series like this. Okay, so series summation n n raised to minus 4. What is meaning of that? It is actually 1 upon, so it is actually summation, it is actually summation n 1 upon n raised to plus 4, and you will find that it will be compared with this, giving you value of n equal to 4, and note that n equal to 4 is greater than 1, therefore the series is convergent. Are you getting my point? So that is regarding your p series. So p series converges. Okay, so fix that p series is nothing but summation n from 1 to infinity 1 upon n raised to p. So if p is greater than 1, strictly greater than 1, it converges, and if it is strictly less than 1, it diverges. That's all. Okay. Now next part is the comparison test. Now see, we have all in this chapter we have tests only. Test means like we go for a blood test. Okay, so if we go for blood test, then certain blood test, we have various types of blood test. Okay, we can go for BC, we can go for complete blood test. Okay, we can have partial blood test. So we have various types of blood test. Okay, so depending on prescription given by doctor, we go for the blood test. So in similar way, we have our test for checking the convergence and divergence of series. So if what you have series, you can check convergence and divergence of that series, okay, with some test. Okay, and that tests are in front of you. So first test we have seen is of p series. So see whether it is p series. If it is p series and if p value is greater than 1, it converges, and if it is less than or equal to 1, it diverges. Okay, now next test is called the comparison test. Now see what is comparison test. Suppose that you have two series. Okay, this comparison test contains two series. First series is summation n from 1 to infinity un, and second is also of same type, but here in place of un we have with bn. Are series of positive terms. Suppose that these two are series of positive terms such that, so what is such that, nth term of first series divided by nth term of second series, okay, its limit as n tends to infinity if it is equal to L, and if it is a finite not equal to 0 value, okay, then what, both series summation un and summation vn what, converge or diverge together. What is meaning of that? If one is convergent, other also will be convergent. Okay, if one is divergent, what, its other also will be a divergent if this condition is satisfied. Okay, once again I will repeat, what is comparison test? If summation un and summation vn are two separate series of positive terms, okay, and if what, nth term of first series divided by nth term of second series limit ends to infinity, this ratio what is a finite, and if it is not equal to 0, greater than 0 and finite not equal, see what is meaning of that, it should not be infinite and it should not be 0, and even it should not be negative. So if it is happening, okay, then that both series, if one is convergent, other also will be convergent, if one is divergent, other also will be divergent. That is called comparison test. Okay, now see how we are going to use that comparison test. Now there is a second test that is called a D'Alembert's ratio test. Now suppose you have summation un is a series of positive terms again, and if what, un plus 1 means after un we have un plus 1, so un plus 1 divided by un, if you take a ratio of it as a limit n tends to infinity, and if it is equal to L, and if that L what is less than 0, the series converges. If it is greater than 0, the series diverges, and if L is equal to 1, then in that case your test is failing, that is a D'Alembert test fails if this ratio limit as n tends to infinity is equal to 1. So you are required to have some another test. This test is not working. Okay, so what is next test is a Cauchy test. What is Cauchy test? Suppose that again you have summation summation un and from 1 to infinity is a series of what, positive terms, and if limit n tends to infinity, un means nth term of what series, raised to 1 by n means nth root. Okay, if this value is equal to L, and if that L is less than 1, the series converges, and if L is greater than 1, the series diverges. Okay, so what, using these three tests along with P series, we can solve maximum problems of your syllabus. Okay, so let us have the first problem. What is the first problem? Solve the problem on P series and geometric series. Okay, so let us solve the problems on your P series and geometric series. So determine if the following series converges or diverges. What is series given to you? Limit n tends to infinity. Okay, summation n from 1 to infinity, n square plus 2 divided by n raised to 4 plus 5. What is meaning of that? What, this series has nth term. Okay, so this is your un. So this is your un. Okay, actually this series what can also be given as, see, if you put n equal to 1, we get 1 plus 2, that is equal to 3. So 3 divided by 1 plus what, 5 is equal to 6, and 3 by 6 is nothing but 1 by 2, comma, if you put n equal to 2, we get what, 4 plus 2, that is equal to 6, and divided by what, n equal to 2, that gives you so here we have n raised to 4, that is if you put n equal to 2, we get 16. So 16 plus 5, that will become what, 21, and so on. Okay, so you will find that its nth term, so its nth term is given by what, n square plus 2 divided by n raised to 4 plus 5, that is nth term. Okay, now what I am going to do, okay, let me separate out this. Okay, I am having here what, n square divided by